I'm here to talk to you about our project ARTSI that we developed at CSU. Again, a different CSU than you're probably used to hearing about here. So I wanted to kind of provide a brief introduction to who Columbus State is first, just so you kind of know where we're coming from. We're a very diverse department. Earth and Space Sciences, a lot of different groups. And my goal as the new atmospheric scientist was to try to find some sort of common ground between these groups and try to get people interested in meteorology. So we developed ARTSI, where we want to take students into an immersive field experience where they can really get hands-on experience with meteorological instrumentation and field work. And we can also contribute to the scientific record of this event by providing the response of the lower atmosphere. We're doing this with instrumentation provided by NCAR through an educational deployment loan. And we're going to have two 10-meter towers. Again, we're focused on the lower atmosphere, looking at how the temperature, wind speed, and all these different properties change. Actually, and we're going to be doing this in Grand Island, Nebraska. Why Grand Island? First of all, we're in the path of totality here. So unlike Georgia, we'll get that 100% coverage. Also, unlike Georgia, we don't have to worry as much about clouds in Grand Island. Higher altitude, a little bit less moisture. In fact, if we look at a map of cloud cover, we see that in the Grand Island area in August, hopefully about less than 50% chance of clouds, whereas in Georgia, those values are somewhat higher. In addition to cloud issues, we're also worried about what we call exposure. We want to get away from trees, we want to get away from terrain. We like that nice, flat, wide open spaces so we can measure wind speed and temperature and all that good stuff. Lastly, Grand Island promises a great community outreach opportunity, and that's where we're going to deploy our first station at the Stir Museum of the Prairie Pioneer. They're having a very large Eclipse event, and we're going to have our station set up. We'll have live atmospheric data streaming, and our CSU students will be able to actually talk about those data. And additionally, we want a good research station where we can have data to actually make science with. And that's where we're going to deploy at the Central Nebraska Regional Airport. Better exposure, away from people, hopefully, so we'll get really good, clear data that we can look at the response of the atmosphere. What are we going to expect? Well, of course, conditions kind of similar to nighttime. We'll see changes in wind speed and temperature, of course, your radiation. And we're also looking for a response in the fluxes. Now, this isn't necessarily new research. This has been done before. And so we know what this should look like. We're going to see a drop in radiation as that eclipse occurs. And with that drop in radiation, we're going to expect a response in the surface temperature. And what's neat about this is we're going to see that temperature at the lowest part of the atmosphere decrease the greatest. And what that's going to do is actually flip around what we call our atmospheric stability. So you'll wind up with temperature actually increasing with height in the lower part of the atmosphere. And this usually happens about 5 minutes after totality, as we can see up here in this image. And with that change in stability, we also see a change in that flux of heat. All that energy, where's that going? Is it going away from Earth? Is it going toward Earth? And so we'll see that change in both the sensible and the latent heat flux, as well as our turbulent response. We don't know a whole lot about what the wind does. We think that's dominated by the synoptic situation, but we do know that turbulence decreases as that shadow crosses over a location. And so we'll be able to measure that as well. And then finally, as we said, we'll get to see that change in stability, or that situation in the atmosphere where air does not want to rise. It just wants to hang out at the surface, similar to what you would expect at nighttime. And we're not the only ones that are going to feel this event. Plants will feel this as well. Photosynthesis will slow down. We'll see a change in the carbon dioxide flux as well, which has been seen in a total eclipse in Europe, but we'll be doing that for the first time in a total eclipse in the US. So we'll have these data that we can look at. And again, this is an educational deployment. The goal is to get students working with the data to kind of really inspire that next generation of scientists. We're going to also develop activities for a new laboratory manual, as well as in-class exercises. And then finally, at one of our collaborators, the Coca-Cola Space Science Center, we're going to actually develop a planetarium video that tracks the eclipse as well as the meteorological parameters displayed together, as well as some other educational units for folks who visit in the community. Overall, our deliverables, I would really love to get a paper or two out of this, but again, the idea is that this is an educational opportunity for our students and for the community in Nebraska, where we can talk about the science of what we're doing, show them what we'd expect, and hopefully they can enjoy that. So thank you to NCAR, NSF, UCAR, all the people, and and CSU for supporting us taking a van load of students to Nebraska. That's the scariest part of all this.